The next speaker is Samson Adesope, who's currently associated with Poznań University of Technology in Poland. However, originally he comes from Nigeria. The title of the presentation is Integration BIM-LCA Approach in Decreasing Infrastructure Carbon Footprint. The floor is yours.
Good afternoon, everyone. My name is Samson Adesope, a graduate civil engineering from Poznań University of Technology, Poznań, Poland. I am from Nigeria. First and foremost, I want to thank InfraBIM team for the privilege to be presenting in this InfraBIM 2021 conference. Today, I would like to present on the topic Integration BIM-LCA Approach in Decreasing Infrastructure Carbon Footprint. First of all, I would like to speak on the following outline. I will speak on the background, objective, scope, BIM integration, BIM-LCA, result and discussion, and conclusion. Now, we all agree with me that the world is becoming unsafe as a result of our daily activities, especially construction activities. Studies show us that construction activities contribute 40% of global emissions. This situation needs an urgent attention before it will become irreversible in the years to come. And we all know that 2020 has been the start of the new climatic mitigation decade. In recent years, United Nations IPCC declared to cut the emission down by 80 to 95% by 2050. Now, one of the basic European Union Euro 2020 energy strategies is the reduction of total energy of usage by using of energy efficiency improvement. Construction activity sector contribute 1/3 of the total global emission. The building carbon footprint operations are responsible for 35% total energy and 90% of greenhouse gases. So we must find a solution to solve this CO2 problem. Background: in this presentation, I would like to focus more on carbon footprint, embodied carbon, greenhouse gases. And as you all know, embodied carbon is the carbon emission associated with material and construction process throughout the whole life cycle of a building or infrastructure. Now, how can we use carbon footprint, embodied carbon? How can we use LCA BIM approach to solve carbon footprint, embodied carbon in construction? That is what I would like to focus in this presentation. Objectives: in this presentation, I would like to evaluate the effective way of reducing CO2 emission by substituting less carbon materials for high carbon materials in a building, and to achieve carbon emission reduction using LCA approach. As we can see from this diagram, we have BIM versus LCA. What is BIM? BIM promotes the creation and sharing of digital information in a file neutral format within integrated system. The integration of BIM-LCA can reduce time and improve application of environmental analysis, while LCA it helps in calculating environmental impact during the entire life cycle of a building. BIM-LCA serves as a tool to figure out which material could be effective and sustainable in terms of CO2 emission reduction in construction. Now, what are the likely challenges in the LCA in construction? The first one is it is complex in nature. It is time consuming. Data collection and interoperability challenge. We have lack of credible material environmental product declaration from local manufacturer. Well, majority of LCA is done after design stage. Now, BIM-LCA integration 5-step approach. So we have to follow the following steps to achieve CO2 emission reduction using BIM-LCA approach. The first one, we have to import IFC file into BIM tools, exporting the bill of material and bill of quantity from a BIM environment into other tools. Information from a BIM tool can be further processed in a BIM fuel environment. Using BIM plugin that enable LCA analysis, we can use this thing. We can generate LCA analysis and result for interpretation, as you can see from this pictorial diagram. So this is the typical pictorial representation of how to generate BIM-LCA CO2 reduction. We have BIM tool. From BIM tool, we have LCA file, we have BIM plugin, we have LCA. In LCA, we have two types of database. We have generic database and we have EPD. What is EPD? EPD is environmental product declaration, which enable us to assess the environmental performance of a product during the entire life cycle. Now, according what reason for carbon emission reduction? Now, according to US CO2 emission by sector, the study shows that building contribute 44.6% of CO2 emission. Now, as we see from this diagram, we have different emission from different parts of the world. Globally, we have Asia, we have Europe, we have South America, we have North America, we have Africa. So each of these, how can we solve this global emission, CO2 emission, using BIM-LCA approach? Now, problem to solve. Study shows that each year 6.13 billion square meters of buildings are constructed yearly. The embodied carbon emission of this construction is approximately 3,729 million, according to Architecture 2030. Now, concrete, steel, and finishes contribute roughly 75% of total embodied carbon in construction. How can we solve this problem? We must solve the problem of climatic change, reduce greenhouse gases, CO2 emission increment, and reduction of CO2 embodied carbon. Now, these are the solutions. These are the approach we need to follow. And by using environmental product declaration, LCA and BIM approach, and the designer and architects must select the most sustainable material during design stage. Now, scope. In this presentation, I would like to focus solely on how to substitute high carbon materials for low carbon material with nearest CO2 emission using BIM-LCA approach. Now, as you can see from this diagram, we have IFC file, we have BIM tool, we have LCA, we have EPD. We need to follow all these stages to be able to achieve CO2 emission reduction in infrastructure. Now, as we see, infrastructure embodied carbon. So each of stages of infrastructure or construction contribute immensely to CO2 emission. Now, as you can see, we have extraction CO2 emission, we have transportation, we have material processing, we have construction stages, we still have operation stages. So each of these stages contributes immensely to CO2 emission. Now, building life cycle stages, we have different scope. We have cradle to gate, we have from extraction stages to manufacturing stages, we have gate to gate, we have cradle to gate, we have cradle to grave. Now, as you see from this diagram, we have A1 to A3, we have A1 to A4 to A5, we have B1 to B5, and we still have C1 to C. All these stages, so it helps to know which stage of the construction we want to calculate or we want to analyze. Now, as we see from this diagram, it helps us to know we have carry to grade, which which is a total life cycle building analysis in construction. Now, BIM-LCA integration approach, we have BIM model, we have data exchange, we have material quantity takeoff, we need life cycle assessment stages, and we need to generate result for interpretation, as we see in this diagram. Now, we have construction carbon LCA approach. Now, we have material extraction emission, we have raw material processing emission, we have transportation, we have manufacturing emission, down to demolition. Now, as we all know, LCA is a scientific tool for the evaluation of environmental effect of product throughout the complete life cycle, from car to grave. This informs extraction of material, refining, fabrication, transportation, use of recycling and disposable of the product, as well as energy and auxiliary material supply. Now, integration processes. For us to achieve CO2 emission reduction using BIM-LCA approach, we must follow this BIM model to result stages. In this presentation, I try to calculate CO2. How can we solve CO2 emission using BIM-LCA approach? I perform two analyses. The first one is focused on CO2 analysis, while the second one focus on CO2 emission reduction. As we see, the first analysis, I got 629 kg of CO2 equivalent emission. So when I try to do the reduction by changing some high content material, reduce the transportation distance and make use of EPD. So I try to get 501. So this BIM-LCA approach help us to determine the embodied carbon in construction. It assists us to know which of the construction stages contribute mostly to global warming, and it helps us to know which of the construction material contribute mostly to CO2 emission. And as we see from this results, now we see different stages of CO2 emission. Material with high CO2 content. So this approach will help us to select material with low carbon content. Now, conclusion: our daily construction activities have resulted in global warming, which has made Earth uncomfortable for living. Before this situation will reach the point of no return, we must find a means of reducing CO2 emission in construction. This could be achieved by calculating embodied carbon and operational carbon footprint using BIM-LCA analysis. Now, it also is BIM-LCA analysis. It's also in addition to in achieving low carbon sustainable infrastructural environment. Now, for us to achieve low CO2 emission in infrastructure, materials should be recycled and reused. Local manufacturers should declare their EPD, and distance of transporting materials from processes should be reduced. Architect designers should select low carbon emission materials, e.g. ready-made concrete should be replaced with prefabricated and wooden materials. Designers should design for long term rather than a short service life. Now, recommendation: I would like to urge us that if we think seriously on achieving a sustainable and healthy environment, some important regulations have to be introduced. In particular, standards for engineers should be obliged to check carbon footprint. The integration of BIM-LCA will help us in selecting low carbon construction material to achieve optimum carbon emission reduction. Architects, engineers, and designers should focus on carbon footprint estimation. You agree with me that CO2 emission is a global challenge which requires global challenge. Thank you for your attention.
Thank you. That's a very hot topic, carbon footprint. Thank you for your presentation.